Hello, today we are going to take a look at how to use the sum and difference and half angle identities to solve some trig values of angles that are not our standard pi over 3, pi over 2, pi over 4, etc. So first, when we're looking at our sum and difference, we will use these for our twelfths. So if we're here when we're taking cosine of 11 pi over 12, what we need to do is first rewrite that 11 pi over 12 as a sum or a difference of two angles that we know the sine, cosine, and tangent values of. So for example, what we could do is say, how do we get to 11 pi over 12? Well, we could do 5 pi over 12 plus 6 pi over 12, which doesn't really work because 6 pi over 12 simplifies to pi over 2. Great, we know the sine and cosine values for that, but not really for 5 pi over 12. So we have to go back and try a different set of angles that add up to 11 pi over 12. There are multiple different angles that we could use, but here the one that I think about first is we can rewrite this as 8 pi over 12 plus 3 pi over 12. The reason I'm going to pick those is because they will simplify to values that we know. So 8 pi over 12 is 2 pi over 3, and 3 pi over 12 is pi over 4. So once we have that, we want to take a look at our identity. In this case, cosine of, it's cruel when they use u and v because they look close together, but so it's cosine of the first angle multiplied by the cosine of the second angle. That minus or plus means that we change the sign. So in this case, since we have a plus over here, it is going to be a minus sign in the middle, and then sine of the first angle, sine of the second angle. So let's write this out. We've got cosine of our first angle. And since this is addition, the order does not matter. Addition's commutative. You will end up with the same answer no matter what. Cosine of the second angle. And then we change the sign because plus or minus becomes minus or plus. And then sine of our first angle. Sine of our second angle. Then we go through and evaluate all of these trig functions. So cosine of 2 pi over 3 is negative 1/2. Cosine of pi over 2 is 4 is root 2 over 2. Sine of 2 pi over 3 is square root of 3 over 2. Sine of pi over 4 is root 2 over 2. We can multiply those together. And as much as we would like to combine these numerators and get something that looks a little nicer than square root of 2 minus square root of 6 divided by 4, there are no like terms there, so there is nothing that we can do. So that is our cosine of 11 pi over 12. For our sines and cosines of our 12th values, this is what a lot of the answers are going to look like. Now, let's take a look at one of the tangent values. So tangent of 5 pi over 12. This one I'd like to do with some subtraction, just to mix it up a little bit. Our first step, as always with these, is to rewrite that angle, that 5 pi over 12, as a sum or difference of two angles. So let's do 8 pi over 12 minus 3 pi over 12. Little subtraction there. Those will again simplify to our 2 pi over 3 minus pi over 4. Then our tangent identity here is going to work the same way as our cosine and sine ones, where we just start substituting in our angles. So 2 pi over 3 is our first angle. So our numerator is going to be tangent of 2 pi over 3 minus tangent of our second angle. The numerator stays the same because it's plus or minus, which is the same as plus or minus. The denominator is minus or plus, so it is going to be the opposite sign. So we will have 1 plus, and then the product of these two tangents. Then we can evaluate. Tangent of 2 pi over 3 is negative square root of 3 because it's in the second quadrant. Tangent of pi over 4 is 1. Now, just wanted to simplify that a little bit. Now, we don't want our square roots in the denominator, so we need to rationalize. In order to rationalize this denominator that is a binomial, we need to multiply it by the conjugate. So we change the sign. So it will be 1 plus the square root of 3. So in our numerator, we will have to FOIL. So our first outer, when we multiply square root of 3 and negative square root of 3, we just get negative 3. Inner, we get minus 1. Last, we get minus square root of 3. Then our denominator, when you multiply conjugates, you end up with a difference of perfect squares. So it will be 1 squared minus square root of 3 squared. Then we can combine some like terms in both the numerator and denominator. So we have negative 4 minus 2 root 3. And if you're having trouble adding or subtracting any sort of radicals, you can think about them a little bit like variables. Like if our numerator was negative x minus 3 minus 1 minus x, it would be written just like this, except with an x instead of the square root of 3. So when you're combining like terms, treat them like variables and it will work out there. Each of these terms has a negative 2 in it, so we can do the division. So negative 4 divided by negative 2 is 2. Negative 2 root 3 divided by negative 2 is just the square root of 3. Whether you end up with taking tangents of pi over 3s, so we end up with square root of 3, or of pi over 6s, where we get a square root of 3 over 3, your answers are going to look for our tangent of 12ths, are going to look something like this, where we have 1 or 2, and then plus or minus square root of 3, 2 square root of 3. It will be something along those lines. Now let's take a look when we have something that is similar, but not exactly the same. We have something written out here for 3, where we have cosine of 29 pi over 18, cosine of 4 pi over 9, and then so on. This, we don't know the sine or cosine values of either of those angles. However, this looks just like our cosine identity. So when you have one expanded like this, all we're doing is starting with the right side of the equation and then moving to the left side of the equation. So this one, since it goes cosine, cosine, sine, sine, is our cosine identity. And one thing that can trip some people up is thinking about this as, oh, well, the cosine is just covering the left and then we need to deal with the sine. Look at your sum and difference identities where this is the entire identity. So the whole thing is going to just be the cosine of our two angles. So 29 pi over 18. And then cosine, you change the sign, so it will be minus 4 pi over 9. In order to combine these, we will need a common denominator. So multiply 4 pi over 9 by 2 halves. So we've got minus 8 pi over 18. We can do that subtraction. 21 pi over 18. Let's simplify. We can factor out a 3. Well, look, cosine of 7 pi over 6. We know what that is. It is going to be negative square root of 3 over 2. So it looks daunting at first, or it can, but we need to just think about this as our sum and difference identities just going the other way. We have the expanded form. We need to write it as the sum or difference of one of the angles inside that trig function. The same thing is going to happen here. It's not going to simplify exactly like the last one because we have variables, but we're going to do this in the same way. This entire fraction is just our tangent sum and difference identity. Sometimes people get thrown off because, like, all right, well, we know that we're doing the same sign as up here, so it will be 6v plus 4v, and then go through, do the work from there, and then think about, wait, but what about the denominator? It's not that. The entire tangent identity up here, it's somewhere on this. The entire tangent identity is that numerator and denominator. So by rewriting this as tangent of 6v plus 4v, that covers everything that's here. So then we combine the two. So 6v plus 4v is 10v. And since we're simplifying, that is the best that we can do. Let's take a look at our half angle identities. Our half angles we're going to use to calculate eighths. So we've got tangent of 7 pi over 8 here. We can't do this as a sum or difference because we could write this as 3 pi over 8 plus 4 pi over 8 because 4 pi over 8 is pi over 2. We know the values of that. That's fine, except the 3 pi over 8, we don't know the values. So all of these identities have some sort of angle divided by 2. We can rewrite this as tangent of 7 pi over 4 divided by 2. Because when you do that division, you divide a fraction by a number, that number will end up getting multiplied in the denominator. If it helps you to think about it as you're dividing by 2 over 1 and then multiply by the reciprocal of that denominator, you end up with 7 pi over 8. So any of our eighths we'll write as some sort of pi over 4 divided by 2, and the pi over 4, just like this a here, is what's going to get substituted into our identity. So we rewrite this as tangent of 7 pi over 4 divided by 2. Our highlighted angle is what's going to get substituted into the identity. And we've got two different identities for tangent, and there's another one involving a square root, but I would advise against using that for most of these cases. Which one you're going to pick really just depends on what type of problem, what mood you're in. You could flip a coin, doesn't really matter. In this case, let's use this first one. The 1 minus cosine of, and we use 7 pi over 4 because that is our highlighted angle. That's what's represented by this a here. So it's always whatever angle is being divided by 2. And then divided by sine of 7 pi over 4. And now, just like with our sum and difference identities, we are going to evaluate. So cosine of 7 pi over 4 is square root of 2 over 2. Sine of 7 pi over 4 is square root of 2 over 2. Except that this sine one is negative. So here we have multiple fractions. We've got a square root in the denominator. So we might need to multiply by something. So in this case, I'm going to multiply both the numerator and denominator by the square root of 2. We're allowed to do this because it's in the form of 1. Because when we distribute this, when it's multiplied to the 1, well, that's easy. We just get the square root of 2. When we multiply to our square roots of 2 over 2 becomes, which root 2 times root 2 is just 2. 2 halves is just going to be 1. So our numerator becomes minus 1. Our denominator is also negative 1. So we can rewrite this. Since it's divided by negative 1, we can just change signs. So we have negative root 2 plus 1 is going to be the finished product. Now with our sine and cosine values, it's going to be a little more complicated because we have some square roots in the identities, but we also have to deal with this plus or minus. That doesn't mean there are multiple values for the identity, like in this case the sine of pi over 8. It just means that we have to do a little work at the beginning to determine what quadrant the angle is in, so that then we can determine whether the sine or cosine is positive or negative. I like doing this by drawing some axes. You can use whatever acronym that works for you, but I look at this as always study trig carefully, and this tells us which trig functions are positive in each quadrant. Since we're looking at eighths, well, we've got 4 pi over 8 is pi over 2, 8 pi over 8 is our pi, and so on. And this one is pretty straightforward because pi over 8 we know is in the first quadrant. But if we had something like 11 pi over 8, we just need to look and see, oh, well, 11's between 8 and 12, so it would be in the third quadrant, and both the sine and cosine would be negative. But that's just an example. For this one, sine of pi over 8 is in the pi over 8's in the first quadrant, sine is positive in the first quadrant, so this is positive. So we're going to use this identity. You need to deal with the sign, like the SIGN, and determine whether it's positive or negative, what quadrant the angle's in, before you rewrite the angle as your pi over 4 divided by 2. What you do from here is just like with all the other ones, you use your identity and substitute your values in. So we have 1 minus cosine of pi over 4 divided by 2. Then we evaluate that cosine of pi over 4, which is going to be square root of 2 over 2, all divided by 2. If you like 2's, these are the types of problems for you. We don't like the fact that we've got a square root in the numerator here, not the square root, the fraction. So what we're going to do is multiply both the numerator and denominator by 2. We're allowed to do that because that's 1, and that will deal with this little fraction here. So we multiply this out. We end up with 2 minus the square root of 2 in the numerator, and then 4 in the denominator. When we're dealing with a fraction under a square root, we can look at this as the square root of the numerator divided by the square root of the denominator, which is convenient because we know what the square root of 4 is. So this value, this sine of pi over 8, is the square root of 2 minus the square root of 2, all divided by 2. Any of our sines and cosines of our pi over 8s, or if you take a look and use this for a pi over 12, are going to have this sort of nested square root, whether it's a square root of 2 or a square root of 3. So for example, if you had a 12th, you could write this, if you wanted, as cosine, let's do it in a different color. We've got cosine of 11 pi over 6 divided by 2. Use your half angle identity and just use pi over 6 as the angle you're substituting in. You will end up with an answer that looks different than negative square root of 2 minus square root of 6 over 4, but it is going to be equivalent. Thank you for watching.